Welcome back. Today we're diving into pub/sub architecture. This pattern fundamentally changes how our services communicate with each other. Let me explain pub/sub with a simple analogy. Think about your favorite radio station. The DJ is the publisher. She broadcasts music without knowing who's listening. She doesn't care if 10 people or 10 million are tuned in. The radio frequency, like 99.7 FM, is the topic. You're at home wanting to listen, you are a subscriber. Thousands can tune in simultaneously and all receive the same broadcast. So what exactly is pub/sub? It's a messaging pattern with three key components. Publishers send messages to topics without knowing who receives them. Subscribers listen to topics without knowing who sends messages. Topics are named channels that connect publishers and subscribers. This separation, this decoupling, is the superpower of pub/sub. Let's visualize this in a typical system architecture. On the left, we have our publishers' user service and order service. When user service creates a new user, it publishes a user_created event. It fires the event and forgets about it. This is asynchronous communication. In the middle, you see the topics. They're like mailboxes holding messages. On the right, multiple subscribers react to the same event independently. One message from user service fans out to email and analytics services. Let's explore the key properties that make pub/sub so powerful. Loose coupling. Publishers and subscribers are completely independent. Scalability. Add more publishers or subscribers without affecting the system. If your analytics service gets slow, it doesn't slow down user signups. Fan out. One message delivered to many subscribers simultaneously. Async processing improves responsiveness and overall system throughput. Now let's talk about a crucial detail: delivery guarantees. At most once is fire and forget fast, but messages might get lost. At least once guarantees delivery, but you might get duplicates. This is the most common choice. Your code must handle duplicates. Exactly once is the holy grail, but comes with complexity and performance cost. Choose based on your use case, metrics versus orders versus financial transactions. How does the system know if delivery succeeded? Through acknowledgments. The publisher sends a message to the topic, which stores and confirms receipt. The topic then pushes that message to an active subscriber. The subscriber receives and starts processing, maybe writing to a database. If successful, it sends an ACK. The message is marked as done. If something fails, it sends a Nack. The message will be redelivered. This ACK/Nack mechanism enables the at least once delivery guarantee. Let's see what happens when processing fails. The subscriber receives a message and tries to write to the database. But the database is down. We get a connection error. The subscriber sends a Nack to indicate processing failed. The pub/sub system schedules the message for redelivery. This ensures no messages are lost even when things go wrong. A common confusion: what's the difference between pub/sub and a message queue? A message queue is point-to-point, one producer, competing consumers. Think of it like a to-do list. One worker takes each task and crosses it off. Tasks are distributed among workers, each task handled by only one worker. This is great for load balancing heavy workloads. Use queues when each task should only be processed once. Now compare that to the pub/sub broadcast model. Event X is sent to the topic, and all subscribers get a copy. They don't compete, they all react to the same event independently. This is one-to-many communication, perfect for event broadcasting. Use pub/sub when multiple systems need to know about an event. User signs up? Email, analytics, and provisioning all need to know. Let's summarize when to use each pattern. Message queue: distribute tasks to workers, each task done once. Example: video transcoding. One worker picks up and processes each video. Pub/sub, broadcast events to multiple interested systems. Example, user sign-up triggers email, analytics, and account provisioning. 3 different services, all triggered by one single event. Now let's see this in code using Google Cloud's pub/sub client library. First, we define an event message data class to structure our messages. It has event underscore type, user underscore ID, data, and timestamp fields. The to underscore JSON method converts it to bytes for transmission. The from underscore JSON class method deserializes bytes back to an object. This gives us a clean, type-safe way to work with messages. Using data classes makes our code more readable and maintainable. The JSON encoding ensures our messages can be sent over the network. Next, let's look at the event publisher class. In __init__, we create a publisher client and build the topic path. The publish method takes an event message and sends it to the topic. Notice the event underscore type and user underscore ID arguments, these are message attributes. Attributes are like metadata tags, subscribers can filter on them. The dot result, call blocks until the message is published or fails. This gives us confirmation that our message was received by the system. Simple and clean, fire the event and get a message ID back. Now the real magic, the subscriber callback function. This function is called automatically for every message that arrives. First, we extract the event underscore type from the message attributes. Then we look up the correct handler function we registered earlier. If we find a handler, we deserialize the message and call it. The critical part, the try, except block handles success and failure. If everything succeeds, we call message.ack, message is done. If any exception happens, we call message.nack, please redeliver. This is the code implementation of the Ack/Nack flow we discussed. It's a contract between the messaging system and your service. Let's visualize the complete message processing flow. First, we receive the message from the topic. Then we parse it to extract the event type from attributes. We route to the correct handler based on event type. The handler processes the message, your business logic runs here. Finally, we ack or nack based on whether processing succeeded. Remember, at least once delivery means you will get duplicates. Your subscriber code must be idempotent, handle this gracefully. Processing the same message twice should have the same effect as once. Use message IDs to track what you've already processed. Database unique constraints can also prevent duplicate inserts. This is critical for building reliable event-driven systems. Let's wrap up with the key takeaways from today's lecture. First, decoupling is the superpower of pub/sub architecture. Publishers and subscribers just need to agree on topic names. Second, asynchronous communication improves responsiveness. Fire events and forget enables powerful fan-out patterns. Third, understand delivery guarantees and make your code idempotent. Fourth, know when to use queues versus pub/sub for your use case. Next up, we'll explore load balancers for distributing traffic. Pub/sub is everywhere in modern systems, let's see some real-world examples. Social media uses it for notifications and feed updates. Financial systems process transactions and fraud alerts. IoT systems handle massive streams of sensor data. E-commerce coordinates orders, inventory, and shipping. Analytics platforms track events for real-time dashboards. This pattern is the foundation of event-driven microservices. Master it, and you'll build systems that are scalable and resilient. Thank you for joining this lecture on pub/sub architecture. Practice implementing these patterns in your own projects. See you in the next lecture where we'll tackle load balancers. Keep building, keep learning, and happy coding. Rocket.